Hey guys, today we are talking about graphing piecewise functions. This is section 3 in algebra or unit 1. So we're going to evaluate piecewise functions and then we're going to graph them. So what is a piecewise function? A piecewise function, it's basically a function that's represented by a combination of equations. So the official definition is a function represented by a combination of equations. And it corresponds to part of the domain. So like if you look below here, this is a piecewise function. It's split up into two different equations that change depending on the x value. So if you notice on the right hand side, it has like x is less than or equal to 3, and then below that it has x greater than or 3. So it depends on what the actual domain is that we're looking at, what's the x value, and that changes the equation and how we graph it. And then a step function, that's a function that increases or decreases from one constant value to another. So I'm just going to put function that increases or decreases from one constant to another. And remember that a constant is like a specific number that doesn't have a variable attached to it, like 4 is a constant, plus 4, minus 4, something like that. So evaluate the piecewise function for the given values. So now we are looking at that piecewise function. Remember that f of x is just a fancy function notation to say y equals. F of x and y equals are the exact same thing. So for f of 0, that's like plugging in 0 in place of our x. But we have to decide, does that go into the top part or does it go into the bottom part? And the way that we tell is we look at our inequalities on the right side, because remember that this symbol here is the less than or equal to, and this symbol is greater than. So if x is less than or equal to 3, we plug it into the top equation. If x is greater than 3, we plug it into the bottom equation. In this case, 0 is less than or equal to 3, so we are going to choose the top equation, that one that's still circled. So all that I got to do is plug in 3 times 0, because I'm replacing the x with 0. 3 times 0 is 3, 0, and 0 plus 2 gives us 2. F of 3. So now 3 is equal to 3, so it still goes in that top equation. Gotta check where that equal sign is. So 3 plus 3 is, or 3 times 3 is 9, plus 2 gives us 11. Now the bottom one, I'm gonna go back to this color. As you probably guessed, we're gonna use the bottom equation because 6 is greater than 3. So now I'm gonna plug in place of the bottom equation's x. So now that's just 6 minus 1, which equals 5. Okay, and I just did those in different colors to show you which ones I'm choosing. Now we're actually going to graph these. So graphing this is going to look a little bit different. What I like to do is split this into two columns since there's two parts that we're graphing. The first column is everything where x is greater than 2, and then the second column is everything less than or equal to 2. All right? Then I want to think of this as an equation. Remember that f of x is the same as y. So this is like y equals, where x is greater than 2, we use this equation, 3x minus 4. And where x is less than or equal to 2, we use y equals negative x plus 1, which is that bottom equation. Then what I'm going to do is I'm going to make an x and y table. This is just going to help us pick points. All right. So on the left side, I'm looking at values that are greater than 2, but I also want to pick a value at exactly 2, and I'll show you why here. So I'm going to start at 2, and then just think x has to be greater than 2, so 3, 4. So we got 3 points. That should be good enough. Next, we want to do the same thing on the other side, but now we want values that are less than or equal to 2. So again, we're going to pick 2, and then we're going to pick values smaller, so let's go 1, and then we'll go 0. So that should work. Now, when you're plugging this in, so on the left-hand side, when I plug this in, I'll just use the color here. I'm plugging in this 2 in place of x. So it's going to be 2 times 3, which is 6, and then 6 minus 4 gives us 2. Do the same thing with 3. So 3 times 3 is 9. 9 minus 4 is 5. Do it with 4. 3 times 4 is 12. 12 minus 4 is 8. And we're going up by 3 each time, which you would expect because the slope is 3. So now I'm going to go ahead and I'll finish the other side first. I'll do it in a different color. Okay, so this side's a little bit easier. I'm just plugging in this in place of my x. So negative 2 plus 1 gives me negative 1. Do the same thing with the other numbers. Negative 1 plus 1 is 0. And then negative 0 is just 0. So 0 plus 1 is 1. Now, when I plot these points, so notice whenever you have a less than or equal to, we are going to consider that a closed point that we include on the graph. So when I draw this out, so I'm going to go over 2 down to negative 1. 1, 0 is right here, and 0, 1 is right here. So I know, and I could just keep going on that pattern there. There is the graph of the right-hand side. Now I need to do the same thing on the left-hand side. I'm going to go back to that yellow. I should probably pick different colors so they're easier to see. Let's go ahead and graph 4, 8. That's over 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8 way up here. And then 3, 5 is going to be right here. But now 2, 2, that is the first point that we talked about. I'm going to do an open circle on that. The reason is because x is greater than 2. So technically that's not a real point on our graph. So that's why I'm going to leave an open circle whenever I'm graphing a point with that's greater than or equal to, or greater than or less than, but doesn't have the equal sign like that. Okay? All right, so there we go. We graphed our points and we're good to go. Let's keep going with the next couple examples here. Graph the piecewise function f of x equals x plus 5, 2x minus 1, where if x is less than or equal to 3 or x is greater than 3. Remember, this is y, so I'm going to do my 2 columns again. So now on the left-hand side, this is everything where x is less than or equal to 3. And this is where everything is x greater than 3. I'm going to write y equals x plus 5. And then this side is the bottom equation, which is y equals 2x minus 1. Go ahead and make your x and y table. Another thing that I like to do for this, just to remind myself that you will always have at least one closed circle and one open circle for these. And so to do that, I think about, well, what does this symbol mean? This is less than or equal to. Less than or equal to is going to be a closed circle. So I'm just going to mark that off to the side. And that's what I was talking about, like when we were talking about this circle here, this is our open circle. And on this equation, this side is going to be the open circle. All right, so let me change my color here just so we can see the graph. Let's do that one right there. So for this one, we are going to pick the points 3 and then a couple points smaller. Let's go 2, 1. And then the right side, let's do a different color. We'll do this, whatever that is. Greater than or equal, or greater than 3. So I do want to include 3. So 3, and then we'll go 4 and 5. So we got 3, 2, 1, and then 3, 4, 5. Go ahead and plug those in. I'm going to go back to this color. So 3 plus 5 is going to give us 8. 2 plus 5 is going to give us 7. And 1 plus 5 is going to give us 6. Go back to this. Plug in 3 into this x up here. 3 times 2 is 6. 6 minus 1 is 5. And then 4 times 2 is 8. 8 minus 1 is 7. 5 times 2 is 10. 10 minus 1 is 9. So now we have our points here. So I'm going to start with the right side, since I have my color on that. 3, 5, I go over 3, up 1, 2, 3, 4, 5, and that is an open circle, because remember, this is my open circle side. And then I go over 4, up 7, which is right there. And I only do the one open circle, because that's I call it the boundary point. That's the point where it changes from open circle, and then everything else beyond that is a closed circle. Okay, then I'm going to go back on the left-hand side. I'm going to change back to my other color. 3, 8. I go over 3, up 8, which is right here, and this is going to be a closed circle. 2, 7, and 1, 6. Draw my points together, and there we go. We got a graph. So it's not too bad once you actually get the points in the tables. The trickiest part is figuring out what are your boundary points. So where do you have closed and open circles? And then making sure you're plugging in the proper points into the proper equation. Okay, last one here. We are going to save example 5 for an in-class just because it's kind of a tough topic to learn about online. So this one is a little different because f of x equals 2. So whenever it equals a number, remember when we've talked about our first couple days, whenever it equals a number, it's either going to be a flat line, horizontal, or a perfect vertical line. In this case, when I do my 2-column split here, this side is x less than 1, this side is x greater than or equal to 1. This side is going to be an open circle because it's a less than symbol, it doesn't have the equal to. This one's going to be a closed circle for everything. And then this is going to be y equals 2, and this side is going to be y equals negative 1/3 x plus 5. I'm going to go ahead and make my table. On the left-hand side, I want to include my boundary point, which is 1, and then everything less than that, so we're going to do 0 and negative 1. And then the other side, my closed circle side is going to be everything at 1, and then 2, 3, because it has to be greater than. Except for this one, let's actually choose nice points, because if you notice, the slope is negative 1/3, so let's pick multiples of 3. So 3, and then we'll do 6. Give us some nice points. So this time I'm going to do this color on the left-hand side. Now, whenever it's y equals 2, the y value is always 2. So that just makes this side super easy. And remember, like I said, it's going to be a flat line. Now on the other side, we'll go with this color. When I plug in 1 in place of x, so I take that, I plug it in up here, I get negative 1/3 times 1, which is negative 1/3 plus 5. That's going to be a weird number. It's going to be negative, if you type it in your calculator, 4.6 repeating. So we're just going to approximate when we graph that. If you plug in 3, negative 1/3 times 3 gives you negative 1, and negative 1 plus 5 is 4, positive 4, excuse me. And then when we do the other side, oh, let me backtrack here, I apologize. This should be a positive 4.6 because the positive number that we're adding down here is going to be bigger. So this is positive 4.6 repeating. This is going to be positive 4. And then when you plug in 6, 6 times negative 1/3 is going to give you negative 2, and negative 2 plus 5 gives us 3. So I'm going to go ahead and graph those. So over 1 up 4.6. So 1, 2, 3, 4, just a little bit up there. It's a closed circle. And then over 3 up 4. And over 6 up 3. So here is my line as best you can. And then on the left-hand side, let me switch back to that other color. 1, 2 is over 1 up 2, 0, 2. But I have to be careful with this one because this should be an open circle for my first point. And the reason it has to be an open circle is because in order to be a function, it has to pass the vertical line test. If it's an open circle, it's technically not a part of the graph, so this one does pass the vertical line test because of that. And there's our graph. So now I know these might be really confusing, and I don't want anybody to panic. Like I said, we're going to do number 5 together. That's a step function. But please try to attempt the problems here. Do the best that you can, and we're going to review this a lot because it's a difficult concept. Please let me know if you want some extra help one-on-one, and do the best that you can with what we got so far.